Thanks for joining us. This is the last session of our fluency series. This is going to be about multiplication division, and this is put on by Mount Holyoke College. I am the director of the math leadership programs here, and we offer professional learning customized for districts, free PD via webinars like this one. We have a great community in the WMMP group. We offer non-credit courses, graduate level courses, and a master's degree program. It's our 40th year at Mount Holyoke of supporting teachers to get better as math teachers. So we're happy to have you here today. So what do we mean by fluency? Well, we want our students to be efficient, flexible, and accurate, and to know their basic facts. And by knowing them in an efficient, flexible, and accurate way. The question is, what is the path of getting there? And today we're going to focus on multiplication and division. So if we think about strategies for multiplication and division, a memorized fact is not a strategy. Those who just have facts memorized often are stuck when given a problem that they don't just remember. They also struggle on figuring out how to approach problems that are outside of the basic fact range. And so we want students to be able to use strategies to figure out a problem besides skip counting. Often kids get stuck in skip counting as the only strategy for figuring out a fact that they don't know. So we're going to talk today about where does skip counting come into play? How do we move past skip counting? And how do we get kids to the point where they have habituated their facts? So if we're thinking about the standards, we've got the end of third grade for kids to be fluent to up to 10 by 10 with their multiplication division facts. Today, we're going to look at the K-3 progression, and then we will end thinking about how to really habituate those facts. So I'm guessing there may not be many K-1 teachers here today because it's about multiplication division. So if you are here, please put it in chat that you teach K and 1. We are going to talk about those 2 years. And for those of you who are here and not in K and 1, and if your K and 1 folks aren't here, please share some of these ideas with them, because there's a lot of foundation that can be laid in K to 1 and can be connected to other standards that they do have to work on. So before we get to this fluency benchmark in grade 3, we have to do the conceptual development. So 2 resources that I find helpful in this area are both Figuring Out Fluency in Math, Teaching and Learning by Jennifer Bay Williams and John Sangiovanni, as well as the Learning Framework in Number, which is a math recovery, part of the math recovery series by Dr. Bob Wright and David Elmore Collins. If you're not familiar with each of these, I would highly recommend them as resources. So let's start with our youngest learners in K and 1 and what can happen there. There's no specific standard around multiplication or division in K and 1. However, there's a lot we can do to build around what they do need to do in terms of counting. So we want to use their informal experiences and always link to quantity and context. And specifically, we're supporting them in their counting and making equal groups and fair sharing. There's not symbolic work here around multiplication symbols. So what do we mean by making equal groups and making fair shares? Well, kindergarten and first graders can work with both of these. They know what it means to share and what it means to not share fairly. So we want to, consider those contexts and build on that. So here are just 2 contexts that we could consider. So for equal shares, we could think about snack time, and there are some friends playing, and we have a certain amount of grapes to share. How many does each friend get? So notice I don't have numbers in here because you want to create this in a way that kids are using lots of different numbers and having this as a situation they can work with. So as I said earlier, young children understand sharing and being fair. So we need to capitalize on this. And kindergarten students need a lot of practice with counting. So if we start to introduce experiences where they're counting equal groups or making equal shares, they then are starting to get that informal experience with groups. So equal shares, thinking about snacks, and equal groups, you could think about party bags and stickers. And again, tweak those numbers. Everyone gets a certain amount of stickers when they come to my party. We have 8 people coming. How many stickers do we need? Right. So they're going to have to make those groups. Right. So if everyone's getting 3 stickers, they're going to make groups of 3 for 8 people. And then we're asking how many stickers do you need? So then they're counting all of those. So we're working on a lot of skills that they have to develop in kindergarten and grade 1. So we want to be really intentional about the numbers we're using. So often we have kids playing with dice, which is great. But if you think about these two situations and they only have the dice that's 1 to 6, then there's a 1/6 of the time they're just going to be rolling a 1, and they're not going to be really delving into the math that we want them to delve into. So often making your own cards and using blank cubes to choose the numbers you want them to be working with is the way to go. I know it's a little extra work, but we really are trying to amplify the math they're doing so that every time they're doing the task, they're actually working on numbers that make sense for where they are and push them to develop the thinking. Also, if you still consider the equal sharing context from the slide before, you want to create numbers with your cards or your dice that are going to work out. So if they're flipping over 20 and they're rolling four people are there, we know that's going to work out evenly. But you also want to pick ones that don't work out evenly, so they grapple a bit with, oh, we have some leftovers here. You can also really naturally differentiate both of those contexts as they have worked with them, as well as other contexts you can bring into play by letting them choose their numbers and seeing what happens. When we get into grade 1, we want to be a little more intentional about charting what they're seeing and linking, and having them write down what they're noticing. So one example could be thinking about an always, sometimes, never, and the commutativity. So if we start charting, wow, we notice everyone gets 4 stickers, there are 6 people coming, how many stickers do we need? Or everyone gets 6 stickers, there are 4 people coming, how many stickers do we need? So we can engineer the situation so they're getting these and starting to number, wow, it's still 24, it's still 24, and bringing in other examples like this and starting to chart those out. And they're grappling with commutativity, with addition in first grade. So why not also bring this into play? Another thing to think about in first grade is place value. If we work with tens, we can use these contexts and start having them talk about what they're noticing, right? And start visually charting them these patterns out so they can start making conjectures. So if they start seeing, kids in first grade, they've been counting by tens since kindergarten. They might have that chant down, but now we're connecting that sequence to the actual quantities of groups of 10. And now we've got 6 groups because there are 6 people coming. That lands on 60. So this is a way you can kick it up a notch in first grade as well. And again, those are just 2 contexts. K-1 teachers are just incredible at thinking about ways to just tweak it a bit, and they're still working on the important mathematics. The other thing that's really simple that can happen in kindergarten is as they're counting, you want them to be counting equal groups. So instead of just giving them a collection of discrete counters and saying how many are there, or get me 18, give them materials that show equal groups and have them count those. So obviously the dice patterns are really important in the early grades for various reasons. So we want to capitalize on that. And we want to start asking questions, how many pips or how many dots and how many twos. So they're starting to grapple with the total dots here. This is to us, we see the 6 groups here very clearly. They're set up in a doubles pattern, right? 3 and 3. So we want to use those structures to help students. But for young children, being able to say that there are 12 dots and also 6 twos is not as simplistic as you might think. So you want to give them those opportunities with the materials. So we don't want to forget about, we got the 3s and the 4s also, and we can be thinking about 10s too, right? So we can use our tens frames. You can make small ones and they're counting those and seeing how many 10s are there, how many dots are there. So in terms of kindergarten and first grade, we're linking these to other standards that they're working on, but we're really helping to lay the foundation, not the formalized foundation of them understanding the X sign and what that means, but they're starting to grapple with equal groups, equal shares, and combining and counting equal groups. Those are the 3 areas that we want to help K-1 build into their practice. So grade 2, we get to grade 2, and now we actually have 3 standards related to multiplication you see two on this page. The first one, I just kind of abbreviated. Again, these are standards are based on the Common Core, but they're starting to grapple with the structure of odd and even numbers. And so we're looking at, right, groups of two, and how that plays into odd and even. We're also, OAC4 brings in the rectangular arrays up to 5 rows and 5 columns. We bring in some notation, but if you notice, the notation is still about addition, repeated addition. Okay, that's not to say you can't bring in the multiplication notation, but you don't have to. And I actually think I think it depends on your group and what they're noticing. But it's not like something that they have to leave second grade understanding that what 3 times 2 means symbolically. Let's look at some grade 2 experiences that we can do to, again, support what then has to happen in grade 3. So we know from our standards, we've got arrays up to 5 by 5. This is the third standard that's in there, that verbal sequences skip counting by 5s, 10s, and 100s. So I would also put 2s, 3s, and 4s in there to support third grade. And if you think about what just happened in K-1, right? So if you're here today and you are lucky enough to have vertical team meetings K-3, we could talk about this strand and how this builds each year. So, 2, 4, 6, 8, 10, like that's a chant that kids work on. 3s and 4s, not so much. So if there is time in second grade, bring in those 3s and 4s, but obviously you want to focus on your 2s, 5s, and the 10s mostly. So what are some things we can do? So if you were here at at our early numeracy session, we talked a little bit about treasure hunt, and we sent the treasure hunt video in the follow-up email. So you can use that game to be counting, but to be skip counting. So I'm not going to go over that game. We'll also include it in the follow-up from here. So I wanted to give you a different thing to think about. So let's think about using our 10 frame structure to help with the skip counting. So this is just going to show the 2s. And what's lovely about this is kids have been working with 10 frames and 5 frames, hopefully in your schools, since pre-K and K. And so if we have cards, and they can flip a card and start saying this sequence. You can start by just doing it straight across. What I like about bringing it into this structure is they start to notice some patterns. Okay, so just look at this and think about, what patterns do you notice? I apologize that this is not an interactive webinar. It's very weird for me to just talk at you for 30 minutes, but I know you're all busy and we can kind of get through more this way, and hopefully they'll give you some ideas to bring back to the classroom. Let's look at another example of this, right? So if we're thinking about 3s, we can now distance the setting a bit and have some cards flipped over, and then be asking them what are the ones missing. So obviously you're doing this after they've worked with that sequence a bit, and you want to work with the sequence forward and backward. We want kids to know that it goes 30, 27, 24. That's going to help us with some of our strategies later on. So at one point, you're going to have them all flipped over, and you're going to see if they can say it and then just check, as they go. And then what's also nice about this structure is you can start highlighting, not literally highlighting, but I did on this slide, but you can start asking, where's the 4th multiple, right? And they can point at it. Do you remember what that is? So they're all shown here. But with that 10 structure, they can easily tell you which one's the 6th one, which one's the 9th one, because they know that from their 10s frames. So that can help with this. So often folks are skip counting, they get that sequence down, which is a great first step, but they can't tell you that 16 was the 4th one I said, unless they start counting on their fingers, again, which is another good strategy. But if we start using this visually, they might be able to visualize that 10 pattern. Where was the 16? Oh yeah, it was the 4th one. So it can be a way to help with that. And then also just, what do you notice about the 5 pattern, right? They're going to notice, well, you're going to just ask them what they notice. Hopefully they're going to see that it ends in either a 0 or a 5. The 10th one is a 50, right? So you can be thinking about, what does the 10th one look like on the 4? Oh, it's 40. What about this one? This one. So there's just a lot of patterning that you can start bringing into play. So that's just about the verbal sequences. We also want to talk about linking the quantity to it. So I'm going to talk about these 3 settings today. We're all familiar with the rectangular array. It's in the standards. I'm not going to spend a ton of time on that. But we want to make sure kids are linking. Once they've got some of the sequence down, we're linking the quantity to it. So what do I mean by n tiles? So here you go. So I'm going to ask how many twos, how many dots? How many twos, how many dots? Again, you notice the way these are coming up, where it's a supportive setting, they're starting to use that tens frame structure to help. If they are pretty good with their 5 and 2 is 7, right? They're going to see that there are 7 here. So these are end tiles, and they really build nicely from what kids know about tens frames and 5 frames. So this one, you notice I built across. You also want to build them this way. And again, you're asking the question, how many 5s? Oh, there are 2 5s. How many dots are there? And so as you build this way, that's getting them to start seeing the groups as horizontal groups versus vertical. Kids, depending on your kiddos, some see it this way first and others see it the other way. I learned that really clearly when I worked with my son. Now there's about a 50-minute presentation that we'll link to at the end or in the follow-up email, that if you really want to dig in more to multiplication, you can watch that. We're taught so often with the arrays that we're supposed to talk about these rows as the group, but kids, I mean, the columns are a group too. So we need to make sure we're building both of those so that we're honoring how kids see it, how they first see it, and making sure they can see it both ways. So again, we're working on our 2s, our 5s, the 10s are built in here. And then we also want to start screening, right? So if we show them quickly, and then we're screening, so they're not always doing that counting. So they're seeing, let me go back to that and try it one more time. So you're going to see some dots. I'm going to ask you how many dots and then how many 5s. So in real life, it would be faster, so that they're getting a quick image of that. But you saw those 5 groups of 5, and I had them arranged also in a 10 frame. So you can use those too. Some kids really gravitate to that. So remember, grade 2 has a 5 by 5 array. So I just want you to remember, kids might be seeing the group like this. Groups, if you say to circle 3 groups of 4, they might circle them that way, and that's okay. It's just a convention that we're trying to read rows by columns. So we want you to be flexible with that. And, you can use color to help them see it the other way if you want them to see it the other way at some point. So in grade 2, just to review, we're working on the verbal sequences, arrays up to 5. And what I'm also suggesting is that you also think about using some other materials to support them with their skip counting, as well as the up to 5 piece. So we get to grade 3, where we've got to consolidate the conceptual understanding. We really need to keep visually modeling what's happening to consolidate the conceptual understanding. And then we can take the visual modeling to really help them see the relationships. We're going to formalize that notation, make sure they understand, what that X sign means, and we're going to work towards habituation. So let's look at some of the relationships that we want to make visible for students. And when I say make visible, I don't just mean symbolically, I mean with quantity. And I was a 3rd grade teacher for years. And in my brain, I thought I was really being helpful, saying, just letting them know, well, if you know your 2s, just double that for your 4s. Look, and I would show them the equation, and look, the answers are just double. That wasn't good enough. I needed to get them to see the visual piece of it. So these are some of the relationships we want to make visible in 3rd grade. Learning our 2s, right? 2s is related to addition. So 2 groups of 6 is 6 plus 6. You could also think about 6 groups of 2 is also 6 by 6. So this is a different array. This is a dot array that you can use to help build the relationships. So 4s, we could relate to 2s in double. So we've got 2 times 6 here, and then we can relate that to 4 times 6. We can also show that with the arrays by using some color. So I'm not saying don't use this, but for some kids, they're going to gravitate more to the dots because they're seeing the 5 plus structure, right? You notice there's 5 black and then it gets a different color. That's built in, so it's a bit more supportive. But for other kids, the dots are overwhelming, and this setting is better. You can also demonstrate these relationships with Unifix cubes and having, you know, 3 groups, in this case, 2 groups of 3, 2 groups of 3 with Unifix cubes, and help them see it that way. So 5s are half of 10, right? We want them to see that. So you can show them the 2 groups of 10, and then look, 5 is half of it. Multiples of 10 and subtract a group to get our 9. So the 9s trick, with the fingers, we want to let go of that. Doesn't help students, besides just maybe saying a quick answer, and often they even mess it up in that sense too. So let's show how the 9s are related to 10s, because we want to get the 2s and the 10s as some of the first facts that they've got. So we can easily see how it went from 4 groups of 10 to 4 groups of 9, and it's just you're letting go of those 4 there that you've got in yellow. So got about 5 minutes left, or 6. So once we've built the conceptual understanding and they've had enough time to see these visual relationships and you've had conversations about them, it's about helping them move that into habituation. And so there's a lot of places to start. The white book that I showed you in the beginning, the Learning Framework and Number, suggests going with these 5 ranges. Others have a different approach, and I'll show you that at the end. But let's think about these first 3 ranges right now. Ranges 1, 2s and 10s. If kids have those down, there's a lot they can build on. And we talked about the 2s, relating that to addition. So 2 times 6 is just 6 plus 6. And hopefully they've got their doubles facts down from addition. 10s, we know there's a great pattern for 10. So that's one we want kids to have in place. And then we talk about low times low, meaning 3, 4s, and 5s times 3s, 4s, and 5s. So before we move to low to high. So let me just show you an example. If kids have these range 2 facts down, they can also use those to create the others. So for example, if we think about 7 times 3, it is just, or 3 times 7, it's just 3 times 5 and 2 times 5. So if you've already done your range 1s with the 3s and they know those facts up to 5, so this doesn't say know all of your 3s facts, know all of your 4s facts. That's not what range 2 means. It means know your 3 facts up to 5, up to that 5th multiple. Remember, grade 2, we're going up to that 5th multiple in the array. So they've got some knowledge there. How do we link to it? And then you can use that here. They already know 3 times 5 is 15, or 5 times 3 is 15. And they also know 2 times 3 is 6. So now they're using their addition to add that together. Instead of thinking as 7 times 3 as 3, 6, 9, or 7, 14, 21. We're trying to move kids away from skip counting by showing these visuals and helping them see the relationships. So again, range 1, range 2, if you get those down, you can then really parlay range 2 to help with range 3. And then what's left is you've got range 4, which is our high times high. And range 5 is actually after, 3rd grade, factors greater than 10. So we think about range 4 and what's left. If we've consolidated the commutative property, which they've been looking at now in 1st grade, they've consolidated it for addition. So we want to consolidate it for multiplication before we get to the habituation. We need to consolidate that property, because then we have less facts to learn, right? So once we get to those range 4, high by high, this is all that's left. They've already learned their 10s. And notice I don't have 7 times 6 down here because they learned 6 times 7, right? Or you could reverse it. Maybe they learn 7 times 6 first, and so they don't have to think about 6 times 7. And in yellow, you got those square numbers. There's lots of great activities to explore square numbers, and often that's some of the first facts that kids are excited to learn. So I put them in yellow here because they might already know those. That's a great exploration to do with your arrays. I don't think I figured out what a square number was until I was an adult. I just, didn't realize it was actually could be shown as a square. So that's a great exploration, hands-on exploration to do. So there's not many left there. So let me show you this again. This book also talks about, we've talked about doubling a bit. We showed it earlier with some of the models. And so this book talks about kind of these three chunks. And I chunk them out as doubling. Want kids to know how that works. Known facts. And if they know a fact, then they can recognize they can add a group, subtract a group from that facts. The 10s to 9s is a subtract a group strategy. And then if they know their squares, right? So if they know times 5 times 5 and they see 5 times 6, they're just, adding a group to it, or 4 times 4, 4 times 5, they can build off of that. So that middle column is really helping them build on something they know. Because kids come in and they remember certain ones. We want to really build on that. And then really the research is pretty solid out there from Van de Waal to this book, that it's really about thinking multiplication for division. Now that said, depending on how you pose your questions with like this one. So if you say how many dots and they tell you there's 25 and then how many fives, if you start with that total and then you're asking the group, you can connect that to that's division. You start with your total and then you're telling me, how many groups are in there. So you want to make that clear. You want to ask those questions both ways. So in summary, we got K&1 informal experiences, always linked to quantity and context, including counting, making groups, and fair sharing. Grade 2, we've got those verbal sequences up to 5 to 5 on the array. They don't need to know those facts up to 5 and 5, but if they play enough with them, they're going to start knowing some of those, which are our range 2 facts. And we're always visually modeling relationships. Grade 3 needs to build on that conceptual understanding, formalize the notation, and get going with the habituation with that practice. So we're going to send you a follow-up resource that has a lot of games for the habituation stage. I didn't talk a lot about that right here because so often that's what people know to do. Go practice this, work on these facts, but we have so much more work to do before they get to that. There are 2 great resources on the Math Recovery blog that this is my former colleague, Dina. This was in the virtual summit that Christina Toldenvold does. Some of you are maybe members of that, but we also have it linked in Math Recovery, and we'll send that link to you in the follow-up. So this one's about thinking about units coordination, getting out of the repeated addition and subtraction world for multiplication. And then this is a session I have done, work that I've done with my third grader at the time, my son. And so you'll see some of the work that I talked about here. Whew, thank you for being here. I'm Marria Carrington. Please reach out via email or Twitter. Please give us some feedback on this QR code. We are considering doing some other 30-minute sessions. So far, the data coming back from the first 2 was that people are liking the 30 minutes. And so it's hard for me to just talk that long and not have interaction. But if it's helpful for folks, I'm willing to think more about what other topics you might want to think about.